We are currently 8 billion people on Earth. But what if there were 100 billion? That's 12.5 times more people. Is it even possible? Would we all fit? Would there be enough food, water, and energy? According to United Nations forecasts, world population is expected to peak at around 10.43 billion in 2086 and then begin to decline. So 100 billion remains far beyond any realistic projection. However, exploring this extreme scenario helps us question the true limits of our planet and better understand concerns about overpopulation. The first question is, could we physically fit 100 billion people? Or more importantly, could we live with dignity? At that population level, the global average density would be 671 people per square kilometer. Surprisingly, only 9 countries in the world currently have a higher density. If we include Macau and Hong Kong, that number rises to 11. Life in these places varies greatly. Some, like Bangladesh and Palestine, face high poverty. Others, such as Bahrain and the Maldives, offer a moderate quality of life. But most of the highly dense territories actually enjoy excellent living standards, leading in human development, GDP per capita, and happiness indexes. 671 people per square kilometer is not as extreme as it sounds. Taiwan, for example, has a similar density of 676 people per square kilometer, yet 2/3 of the island remains relatively sparsely populated.
In a world with 100 billion people, the vast majority would live in large, well-planned cities. This actually makes high density manageable. For example, Barcelona has around 16,000 people per square kilometer without skyscrapers. Seoul reaches 16,500, and Paris has about 21,000. These examples show that we have more than enough space for both dense urban areas and rural zones, as well as agriculture. The next major challenge is food and water. Water scarcity is a serious issue in many regions, but modern solutions exist. Desalination technology is becoming increasingly affordable. Although only 3% of Earth's water is fresh, 70% is salt water, a massive resource waiting to be used. Today, producing 1 cubic meter of fresh water from seawater costs about 40 cents, with energy accounting for roughly 15 cents. As renewable energy prices continue to fall, desalination will become even cheaper. The remaining challenge is brine disposal, but new technologies are being developed to extract valuable minerals from the waste or return the salt safely to the ocean. When it comes to food production, surprising leaders like the Netherlands, Belgium, and Denmark show what is possible. These relatively small countries are among the world's top agricultural exporters thanks to advanced technology, climate-controlled greenhouses, hydroponics, vertical farming, automation, and continuous research. They maximize every square meter of land through crop rotation, genetically improved seeds, and precision agriculture. Even though livestock currently uses about 80% of agricultural land, more efficient systems and alternatives like lab-grown meat can dramatically reduce the pressure on resources. Aquaculture has also grown rapidly and can be further expanded with floating ocean farms in the future with much larger populations. The next major challenge in a world of 100 billion people is energy. Current global energy consumption stands at approximately 183,000 terawatt-hours per year. With 12.5 times more people and a more technological society, this figure could rise dramatically to around 11.5 million terawatt-hours annually. Solar energy is an obvious and important solution. Today's commercial solar panels are about 20% efficient, but laboratory records have already reached nearly 48%. Even at 50% efficiency, covering vast areas would still be required. A realistic and ambitious target of 3 million square kilometers of solar panels could supply roughly 23% of total energy demand in this future scenario. However, solar alone cannot meet all needs. We require a powerful, stable baseload source. That source is nuclear energy. At the 2023 UN Climate Conference, 25 countries signed a declaration to triple nuclear power capacity by 2050. By 2024, 6 more countries joined, bringing the total to 31 nations committed to expanding nuclear energy. Most countries around the world are not shutting down nuclear plants, they are building more. Nuclear power is incredibly space efficient. 1 gigawatt of nuclear energy requires only about 2.6 square kilometers of land, 75 times less than solar and 360 times less than wind. To cover the remaining 77% of energy demand in our 100 billion scenario, roughly 13,400 nuclear power plants would be needed. While this number sounds large, all of them together would occupy an area roughly the size of Taiwan.
Fuel supply is also not a long-term barrier. Known uranium reserves are sufficient for 160 years at current consumption. Even greater potential lies in uranium dissolved in seawater, an estimated 4.5 billion tons, over 500 times current land reserves. Advanced reactor designs, including breeder reactors, could multiply usable fuel by up to 140 times.
So, with smart planning, balanced resource management, and continued technological development, supporting a world of 100 billion people is not only theoretically possible, it could be achieved while maintaining or even improving quality of life for everyone. The numbers speak for themselves. To reach 100 billion inhabitants, the timeline depends heavily on fertility rates and generational types. At a modest 2.5 children per woman, with an average generation length of 30 years, it would take approximately 340 years. However, if societies shift toward 4 children and people start families a bit earlier, around 25 years per generation, this extraordinary population level could be reached in just 1 year. Of course, this remains a purely hypothetical scenario. The United Nations projects that global population will peak around 10.43 billion in 2086 and then gradually decline. The real value of exploring the 100 billion question is not about encouraging explosive growth, but about challenging our assumptions. It shows us that the limits of our planet are not fixed walls, they are elastic boundaries that expand innovation, and technology. Throughout history, every time humanity faced what seemed like insurmountable limits, whether land, energy, or living space, technology and ingenuity have pushed those limits back. From the Green Revolution to modern desalination, vertical farming, and advanced nuclear power, we continue to rewrite what is possible. In a world of 100 billion people, this very change would
Under pressure,
11 million subscribers.
sitting on a kettle, make the
Yes,
steam
I
right.
would finally have earned that
And I don't even know her, but it never stopped
The
me
takeaway is
from
optimistic.
getting closer.
Our planet is far more capable than many fear. The
only
future
gonna
is not
rain
about fighting over shrinking resources,
and it's
but
only
about
gonna
expanding
rain
our ingenuity to match our
and it's only
ambitions.
gonna rain
Whether we reach 10, 20, or even 50 billion, the key will always be the same. Smart
like
planning, technological
rainy
progress,
day in
and a belief in
October,
human potential.
and it's
So,
never
maybe start
over.
having more kids, or at
I'm
least believe a
falling
little
for
in our ability to build a
no,
thriving
it's
future.